void drive distance, float distance meter. So this will be adjusting the drive distance. Okay, so you will call it only with the distance in meters. Okay, and it will drive the motor forward for a specific distance in meters. The robot initially placed on the side of the judo mat. So here is the robot is placed at the side of the judo mat in the blue area. So this is a blue area as shown in figure. Each time the program is run, it cleans a line across. So you should clean just one line and then you turn back and go back to your original position. Okay, so you will drive forward. So here is the sequence. It's us. So the robot will drive forward, okay, until you detect the red. Okay, so if you detect red, you will stop, and when you stop, you will spray. So once you stop, you will spray. So you will move until you detect the red. You will stop and you will spray a circle around the robot. And circle means you need to spray 360 degrees. Then you drive forward 1 meter. Then you stop, spray, and do again and again and again until you complete the 10 times. Okay. So we will do this for 10 times. So we will stop here, spray, then we move 1 meter, then stop, spray, then we move 1 meter, stop, spray, and so on. Okay. Repeat driving forward and then spraying for the entire length of the red mat, which is 10 meters long, making a line that is cleaned, turn 180 degrees around, and drive back across the mat until it reaches the blue safe zone. Make sense? What is required? Okay, state at least one assumption. What is a good assumption here we have? What an assumption here we need to state. Yes, we will start here at the bottom left, but it is not affecting no objects. Okay, maybe. Robot start facing the red. Yes, this is a good assumption. Yes, so we will assume, so it drives straight perfectly is not an assumption, because this with the issues with the sensors, etc. It's not an assumption. It start on the blue zone already. It says it will start on the blue zone. So assuming that it will start facing the forward direction is a correct assumption. Start facing the red mat. This is a good assumption. Yeah, motor A and D are connected to the wheels. Yes, this is given because this is the standard configuration. So given that you are doing all your laps using the standard configuration, we assume that you understand what is standard configuration is. So standard configuration, you have the motors connected to A and D. You have your 4 sensors connected to S1 to S4. Okay, Irina. This is not an assumption. Okay, so spray covers large enough area to stop every meter. So or we have a spray enough to complete one line. We have enough spray to complete one line. This is an assumption. Okay. How this will help Sachin, given that you are doing single line? So the most realistic assumptions here that the motor will start facing the red mat. This is a needed assumption. The second assumption that is important, that we have enough disinfectant to do one complete line. Okay. Okay, can we move forward? Can we move forward? Okay, what is an issue can happen that is not related to the code, not related to the poor battery, not related to the accuracy? What are the issues that can happen? Okay, when arrives near the end of the mat, it will see blue. We can just detect the red to stop and start. Then we do 10 meters. We don't have to check again for blue, Oliver. Okay, so we don't have to check for blue. So once we detect red, we will drive 10 meters. So we don't have to look again for blue. Okay. What an issue? Okay, maybe an issue that the the mat can be slippery from the spray. This is a good one. It's a good assumption. Okay. There is no objects in your path in your line. Okay. So first, it will not get the spray is not damaging the robot. Yes, the spray is not slippery for the wheels. Yes, no one is standing in front of your robot. Okay, so all of these are issues that can take place. Okay, so slippery mat from spray, objects in your way. Okay, so these are issues that can. Now write a function that receive a positive motor power and angle and other parameters to rotate the robot at a given angle. Okay, so let's call this function as rotate robot. Okay, so what will be the return of this? What type of return this function has? Yes, void. So we say void rotate robot, and the inputs here will be int motor power and int angle. Okay, so these are the two inputs, the motor power and the angle. Okay. Okay, what we will do inside this? What we will do inside this? Here we didn't specify a direction for the rotation, correct? We didn't specify any direction for the rotation. Yes, in this case we can say a Boolean direction. Okay, we can say a Boolean direction. Okay. Okay, so if we look at the standard configuration, you have a motor here, This is connected to A, and this is connected to D. Okay. So if this one is positive and this one is negative, you are going counterclockwise. If this one is positive and this one is negative, you are going clockwise. Okay, Aiden and Renato. This is a standard configuration. You can do this as an assumption, but this is a standard configuration. that A on this side and D on this side. This is the standard configuration. Okay, and you should be aware of this configuration because you are doing this in the lab. The gyro will get, so usually when you are measuring degrees, this is a positive direction and this is a negative direction. This is a common scientific direction measurement. Okay, Eden, so if this is the x-axis, up this axis is positive, down is negative. So if you move up, it's positive. If you move down, it's negative. Can we also let them put an angle? Oh, we will see now. We will compare the absolute. We don't care about which direction it is. Okay, so we will look at the absolute. Doesn't matter which direction we are going. Okay. Any questions so far? Any questions so far? Okay, now we can say that motor A equal motor D equal. Okay, let's say that motor A will be positive, okay, to give us counterclockwise, and it will be negative in clockwise. Okay, so motor A is positive in counterclockwise and it is negative in clockwise. Okay, and let's say that the direction is 1 for counterclockwise and 0 for clockwise. Okay, these are assumptions. You can state these as an assumption. Okay? In this case, I will take the motor power to be 1 multiplied by direction plus not direction multiplied by negative 1 multiplied by the motor power. Instead of using if condition, I prefer to use this. So if direction is 1, not direction will be 0, so I'm multiplying by positive 1. If the direction is 0, so this will disappear, and not direction will be 1, so I'm multiplying by negative 1. So this is, I prefer this over using if condition. For motor D, it will be the opposite. Negative 1 multiplied by direction plus not direction multiplied by 1 multiplied by motor power. Make sense how we wrote this? Yeah, this is an assumption. You have to state this for us so we can understand what is going on. Okay, so you can state this as an assumption. You can write it here that I'm assuming direction equal 1 for counterclockwise. Okay, and to be, you can add this as a comment. Okay. Okay, now what we should do next, we should wait until the angle is correct. Okay, so here what we will do, we will use n motor encoder of motor A equals 0, then while absolute of n motor encoder is less than angle, we will do nothing. Otherwise, okay, we will stop motors by saying motor A equal motor D equals 0, then we will return. Make sense? Make sense? Can move forward? Can move forward? Oh, okay, sorry. This is not correct. Okay, sorry. I should use thank you for this. Thank you for this. I'm not using the encoder. Sorry, I should use so the encoder just for driving forward. Okay. So I'm assuming that so here we will say sensor value of sensor 4, and here we will take the absolute of this. So thank you for catching this. This is the absolute. Okay, so Akifa, this is correct. So we will use sensor value of the gyro is less than the angle. Okay. Can you explain the negative one direction part? Okay, I can explain this. So what is your name? Okay, I see a dot as your name. We Ben. Okay, okay, welcome Ben. So here, okay, because we are using the gyro, we have to do the following. Okay, so assume that the gyro configuration will reset the gyro. Before using the gyro, you will do reset gyro of S4. Okay, we need to reset the gyro. Okay, we need to reset the gyro here. Okay, so we need to reset the gyro. Yes. Okay, Ben. So what is your question, Ben? You asked about the negative one, correct? Let me click this. Okay, so let me go back here. Okay, so don't understand the logic behind setting the robot clockwise or counterclockwise, like the part where you give a motor and the motor D a motor power. Okay, so if you have your robot, this is your forward. You have a motor here. This is motor A. You have a motor here, motor D. Okay, if motor A is driving forward, which means it has a positive power, and motor B is driving backward, which means it has a negative power, what will happen here? That your robot will rotate. Okay, and it will rotate in this direction. Correct, Ben? Oh, you mean in the code? Okay. So let's take motor A, okay? Motor A. When motor A should be 1 multiplied by the motor power. Okay, when it should be 1 multiplied by the motor power. In clockwise or counterclockwise? Yeah, counterclockwise or when direction is 1, okay? And don't forget that direction is Boolean. So I will take 1 and multiply by direction. Okay, so what this will give me? It will give me 1. It will give me 1 when the direction is 1. Okay, what if the direction is 0? It will give me 0. Now, what if I added plus negative 1 multiplied by not direction? Okay, now if direction is 1, what is not 1? Not 1 is 0, which means this term will disappear if the direction is 1. Correct, Ben? And this term will be 1 if the direction is 1. Make sense? If the direction is 0, what we will have? If the direction is 0, this term will disappear, and not 0 is 1, so I'm getting negative 1. In this case, the power will be negative. And I can do the opposite for motor D. Instead of using if conditions, I prefer this over if conditions. Okay? But using if condition is totally fine, okay? No issue with this. Some students will say if direction motor A equal motor power motor D equal negative motor power, and you have to say negative 1 multiplied by, okay, then else you reverse them. Motor A equal negative 1 multiplied by motor power, and motor D is positive. So you can do it with if condition. That's totally fine. Okay, that's fine. Yeah, that's fine. I'm saying another way of doing it. Okay. Okay. Any questions so far? Any questions so far? Okay. It's preferred to reset the gyro before start moving. Okay, so not to confuse it. Questions? Can move forward? Can we move forward? Yes, we can wait 1 millisec 50 after resetting the gyro. Yes, we should wait. We can get gyro degrees of S4. Yes, it works the same as sensor value of S4, like get color name or sensor value of S3. Both are fine. Okay, now let's do this part here. Write at least one additional non-trivial function that has parameters and a main function that calls the functions to program the judo mat cleaning robot. Okay, so what is another function that we can write down here? Spray. Yes, we can write void spray. Now what we need to give the spray? What we need to give this function? Yes, motor int, motor power, int coverage, the angle that we are covering. Okay, now what we will do in the spray. So what we should do in the spray? So in the spray we have motor B. Motor B has the sprayer which need to rotate 360 degrees. So we need, doesn't it always spray a full circle though? In this case, Chiron, what if we decided not to spray a full circle, just to have to do a half circle? Okay, so what if we decided I will do half circle, then I will move and do another half circle, then I will move and do another half circle. Okay, so don't use magic numbers. Okay, try to make your code generic. Let me bring this here. Okay, so we will do the spray function. So the spray function would work with motor B. Okay, so we'll take the power and the coverage. So we will start by saying motor B equal here it will equal the motor power. Whatever the motor power is, it should be non-zero value. It is specified here. It should be a non-zero value. So motor B equal the motor power, then n motor encoder, n motor encoder of motor B equal 0. Okay, so this would be the sprayer angle. Okay, sorry, this is would be how we will measure the spray angle. According to the statement of the question, the motor B is the same angle of the sprayer. Then while n motor encoder of motor B is less than the coverage, do nothing. Otherwise, stop the motor. Motor B equals 0. You stop the motor and you return. Make sense how we would do the spray function? Okay, now let's go to the main code. Do we reset the n motor encoder in the beginning? Yes, we reset it here. Okay, why we use the encoder and not the gyro? Okay, so here there is a difference. The gyro is measuring the angle. So here is the gyro is measuring the angle of the robot. Okay, to this robot we attach a sprayer. This is motor B, and we need the angle of the sprayer, which is not the gyro. It's different. The gyro is giving you the angle of the whole robot. Okay, we need the angle of the motor B, which is attached to the sprayer. So motor B is driving a sprayer, and this sprayer will rotate 360 degree. I need this angle to be 360. The angle of the motor B, the angle of the encoder, not the angle of the robot. The gyro is the robot angle, not the motor angle. Make sense, Ian? Okay, now let's go to the main function. Okay, so int main, and we will write our main function. So what should be in our main function? What should be the start in our main function? Okay, sorry. It's my mistake. Okay, so my bad. So yeah, task main. So what should be in the in the main? Yeah, what should be in the main? Sensor configuration. So what is the main of sensor configuration? So we are given a function that do the sensor configuration, and this function is called void configure sensors. So we'll start by configuring sensors. For void configure sensors. Okay. Okay. What next? The return, unless this function is not added. So if the function is not returning anything, once you have the closing braces, it will return. So you can remove the return if it has a void. Okay, if it has a void, you can remove the return. Okay. Okay, right. Okay, so what should be next after we configure the sensors? Okay, so this will configure our sensor. Yes, drive until we detect the red mat. So first we need to get from the blue until we reach the red mat. So in this case, we will say motor A equal motor D equal. Here it is up to us what should be the power we use to drive. Okay, so usually I drive to drive equal say 50, and I will use this as my power. Okay, so drive power. Okay, so this will be the power to drive forward. Okay, then while sensor value of sensor 3 not equal integer of color red, do nothing. Okay, so we will drive until we hit the red. Correct? Make sense so far? Instead of using this, we can say get color name of sensor 3 not equal color red. Okay, or this one also works. Okay, either one is fine. Now we reached the red mat. What we should do here? We should spray. Okay, stop motors, spray and move. Okay, so how we do this? Okay, so we will say motor A equal motor D equal 0. do we have to use a return if it is a void function? I said no, it's optional. It's fine. If you add it, that's fine. If you didn't add it, that's fine. Okay. Because the closing braces will act as a return. Okay. Is it okay, Tom? Should we move? Okay, you all. Now we stop the motor. Then what we need to do? We need to spray. Okay. So the spray function, you will call the spray. Okay. And here we can define an int constant spray power equals, say, 20. It is a non-zero value. Okay. So we will call this with spray power, and we can say also int constant spray coverage equals 360, and we will call this with spray coverage. Okay. Now what we should do after stopping and spraying? What we should do next? Set up a while loop to drive forward, spray, repeat until end. Okay, so how we do this? Should we do while or should we do for? Okay, so we either is fine. Okay, either is fine. So we can say for num stops. Sorry, say it's count int count equal 1 and count less than or equal number of stops. Okay, and this has to be defined capital num stops, and I will define here a constant int constant number of stops equal 10. Then we can say count plus plus. Okay, this is one option, is using for loop. What is another option we can do? What is another option we can do? Okay, let's take this option and see. Okay, there is another option here. Okay, which is using while loop. No, not while less than 10 Chiron. Okay, not while color is red. Okay, not while not red. No. Okay, so here we know that the robot is here, and we know that we will drive 10 meter. Okay, so I can start by saying n motor encoder of motor A equals 0. Then I will say while the absolute value of n motor encoder of motor A, okay, is less than the distance in meter. Okay, so what is the distance in meter? It's 10 multiplied by 100 multiplied by 180 divided by pi multiplied by 2.75. I will do the following. Okay, what I will do, I will derive 1 meter, stop, spray, and repeat. Okay, clear how we will do this with while? Clear how we will do this while? While color equal color red, kind of. We can say while color is not blue. You know that blue will be at the other side. Okay, we can say that while color is not blue. Correct? So also we can say while color not blue. Which while condition, in general, Chiron, or for this case? The 100 to convert it to centimeter, yes, because we know that the wheel radius, this is the radius of the wheel, is 2.75 centimeter. So this is to convert it from meter to centimeters. Okay, Sachin. Why I use the absolute? Okay, it is not good to put within the while loop that you are having the motor power adjusted, but we are not looping on the motor power adjusted. Okay, we drive stop spray, so this will be repeated, not continuous. Okay, the problem if you do while, okay, condition motor A equal motor D equal 50, you will keep setting the power 50 at the speed of scanning of your while. So say your processor is doing 100,000 scan per second. So you are setting the motor power 100,000 times per second at 50. This is not recommended. In this case, what we will do, we will adjust the motor power outside, and we will while on nothing unless we stop it. This is what we don't like to have inside the while loop. But what we are doing here, we are driving 1 meter, then we are stopping and we are spraying. This is what we are repeating inside the while. So that's fine to have this inside the while. Okay, it's not like a generic, you cannot have anything inside the while. You cannot keep adjusting your motor power inside the while loop, because this can damage your motor or your motor driver. Okay. Okay. So here I need to drive 10 meters. So I will say I will reset my encoder, and I will say while the distance is not 10 meter, I will keep driving. And within this while loop, I will drive 1 meter, stop spray, drive 1 meter, stop spray, drive 1 meter, stop spray. Why we prefer this over for loop? Why we prefer this over for loop? We prefer this over for loop if you drive the 1 meter, but say you drive 95 centimeter due to error. Then you will drive another 95 centimeter, okay? And you are driving this 50 or 10 times. So at the end, you will stop at 50 centimeters that is not covered. But when you say while it is less than 10 meters, you have to cover it. But the problem is the last 50 centimeters, you will complete 1 meter into the blue. So how you will make sure that you will cover only the 50 centimeter? You can add here while the distance is less than this and color not blue. So the N motor is outside the while loop. How it will get reset each time? Jonathan. This is correct. So how we can fix this? We can use D. We have 2 encoders. Yes, we can use the other encoder. Yes. Yes, we can use the other encoder. Yes, use the encoder D. Okay. Makes sense. What is the discussion about here for the while loop? I'm not saying that the only solution is the while loop. So if you take this direction, you need to make sure that you are using the other encoder here, and you need to make sure to add that the color is not blue. Why? Because you are driving chunks of 1 meter. Okay, so if you have at the end remaining 10 centimeters that you didn't cover due to error, you need only to cover this 10 centimeter. You don't want to cover whatever else. Okay. Okay, the other way, which is most of the students will do, which is totally acceptable and fine, is using for loop. I will do 10 times. Okay, these are the number of stops. So I will do a for loop. Okay, so this is okay, and you can get full mark for this. You don't have to use while loop. You don't have to take into consideration any error in the encoder. Okay, you don't have to consider this. The question didn't ask for this, so you can go, you can go the easy way. You can do a for loop according to the statement of the problem. This one is totally acceptable, and you can get a full mark. So what you will do in the for loop here, if we do for loop, what we will do inside the for loop? Drive 1 meter and spray 360. So what we will do, we have a function given. Okay, it was given in the question. It's called drive distance, and you call this with the distance in meter. Okay, this is was given to us. Okay, so we will call this. Okay, and you call it with a float distance. Okay, so what I will do here, I will define an int float, and I will call this enter distance, enter distance, the distance between each pass and the other. And in our case, this is 1 meter. Okay, and it should be a float. Oh, sorry. I'm sorry. Okay, float constant. Yes. Int float is good new definition. Yes, it's a float constant. Okay, so we have to define it as a float. So in this case, we will use this function. We will start by drive distance, and I'm driving the enter distance. Okay, and just I will remove this. So I will drive enter distance, then I will stop motors. So I will say motor A equal motor D equal 0. Then I will do the spray. Okay, already we have the spray function here. So I will do the spray. Okay, is it a reason why we made it as a float? Because Chiron, it was given to us. Okay, look, this function is given to us. Drive dist, float dist. I have to call it with a float. So I defined it as a float. Okay. Okay. Any questions so far? Any questions so far? Can we move forward? Can we move forward? Okay, we don't know how the drive dist was written, correct, Mustafa? We don't know how it was written. It wouldn't hurt if you stop the motors and they are already stopped. But it will make an issue if you didn't stop them and start to spray. Correct? Okay, now what we should do next? So this will complete 10 passes, okay? So what we need to do next? Okay, once we reach the end, we need to rotate our robot and we need to drive back to the original location. So how we do this? So we have a function here called rotate. Okay, we have a function called the rotate. We call it with the motor power, the angle, and the direction. Okay, so we will use this function, which we called it as rotate robot. So what we will do, we will use rotate robot, and we will call this by motor power. We call this as drive power, and the angle is 180 and direction is 1. Okay, correct? Correct? Make sense? 180 is not one. It's not a magic number. Okay, it takes you back to your direction. Okay, we can call this as orientation. Okay, so int constant orientation equal 180. Maybe you need to move 445 degrees, and we can call this orientation. Okay, that's fine. But 180 is not a magical number. It's a 180 degree is the reverse direction. Okay. Now, once we rotate, we need to drive back, and we need to drive back 10 meters. Okay. So we have to define here a constant, int, or a float constant, and we can call this total dist equal 10 meters. Yes, you have to say it's a constant, float constant, int constant. So what do you mean? I don't remember what this does. How you define a constant? How you declare constant, Connor? Just say an integer? No, integer is not a constant. Integer is a variable. Constant is different. You cannot change constant while you are in the program. It's a read-only variable. Int, it's a read. Okay, now once we rotate 180 degree, we will drive distance, and we will drive the total distance to go back. Okay, and then we will say motor A equal motor D equal 0, and we will stop there. Make sense? Make sense how we will do the cleaning, Judo Matt? Anyone here? How you use the motor encoders for the spray function? Okay, for the spray function, Sachin, we have motor B. This is motor B, and motor B is attached to the sprayer. And the encoder is giving you 1 degree per degree or 1 count per degree rotation. 1 count per degree rotation. You can see that the motor is attached to the sprayer. So the angle of the motor is the same angle of the sprayer. So if I read the encoder value will be the same angle as the sprayer. I defined it here. I just wrote it now. Float constant, total distance 10. Okay, questions before moving forward. I need to share my screen and show you the code. Any questions? Should we go to the simulation? Just you call it by its name. It depends on the orientation of it. Okay, so usually the degrees are usually clockwise is positive, counterclockwise is opposite. Counterclockwise is positive, clockwise is negative. This is the default. Okay, this is the default. But anyway, you take the absolute and forget about this. But this is the default in any scientific notation, that counterclockwise is positive and clockwise is negative. Okay, let's share screen and do the simulation. Okay, let me know when you see my screen. Okay, now what I have here, I have the robot. Okay, this robot has a small motor here. This motor is called D, and it rotates if you power it. I will assume that this is a sprayer. I have a motor motor B and C. These are the two motors. Assume that this is the red and this is the red mat. Okay, just I can add one color. So assume that this is whole red. Just I have one square as red. Okay, so let's go to the code. So here is the code, standard configuration. I'm configuring the color and the gyro. So sensor type is color, weight 50 millisec. Sensor mode is color, weight 50 millisec. Sensor type is gyro on port 4 or whatever the port is, weight 50 millisec. Set the mode to calibration, weight 50 millisec. Set the mode as rate and angle, weight 50 millisec. And reset the gyro and wait 50 millisec and return. So this will be the setup and configuration. In this case, if you need to add it, Tom, you need to add it. In this case, we don't need to add it because we are rotating 180 degree. We don't have to. If we want to add, we can add it. In this specific question, no, you don't need a direction. You are rotating 180 degree. Doesn't matter how you go 180. 180 is negative 180. Okay, both are the same angle. Now, here is the rotate. So void rotate, power and angle, reset gyro, motor equal positive power, motor equal negative power, wait until the angle reaches the angle, then stop motors and return. You can see here I didn't add the direction, okay? I didn't add the direction because we don't need it. The angle is 180. Then void drive dist, the distance in meter and the motor power. This is different from the question because the question is giving us only the distance, okay? Why? Okay, so Oliver, I said this before, Oliver, that with the simulator, it has issues with the modes. Already it do the modes itself. By itself, it's calibrate and set the angle or the mode to rate an angle by itself. This is the default. And if you do this, it will give you an error. This is something for the simulation. Okay. So just I commented this for simulation purpose. Okay, now here we defined also here all the constants should be capital letters. Okay. So this is the drive power, the turn power, the interpass distance, the number of passes, the coverage angle, and the total distance. In my example, because I have a very limited space, the total distance is 1 meter and the interpass is 31 centimeters. And I'm doing only 3 passes, not 10, okay? Because of the limited. So I will do the standard configuration. Then I will drive forward while not red. If it is red, I will stop and spray. Then I did a for loop from 1 to the number of passes count plus plus. I will drive, then stop, then spray and repeat. Drive, stop, spray, drive, stop, spray. At the end, I will rotate 180 degree. Then I will drive the total distance back with the drive power. Okay, I can add here to stop the motors. Okay, make sense what is the code is? So this is only the code is this part here. Make sense? At the end, once you are driving back, could we also drive while color is not blue? It's risky because you can stop at the blue due to the drift. You can drift to the blue. In this case, you can stuck at the blue one. So if you do 10 meters and you have a drift, so you stopped at the blue. If you did drive while it is not blue, okay, it will stay there. It will stuck there. Correct, Ian? Okay, now let's adopt this code. Okay, let's run it. Okay, so you can see it will drive. Once it detects red, it should stop, and this motor should rotate 360 degree. So it will stop. This motor here is rotating. It will rotate 360 degree, spraying, then it will move. After 31 centimeter in this case, it will stop and spray again and keep continuing. Now, once it reaches the end of the number of passes, it will rotate 180 degree and then start to go back. Okay, make sense what we have here? Any questions so far? Any questions so far? Any questions? Okay, now let's go to the movie one. Anyone have questions before moving to the movie question? Is this clear? Hello? No questions. Okay, was this useful and helpful? Good. Now let's do this, okay? So Fiona, she is rating movies and she think that she need to watch the movie 10 times. So she has a good um, evaluation for the movie, okay? So she wants to make a chart of the ratings. She stores the data for the movie ratings in a file, movie.txt. Each row is the movie title followed by the ratings, and she give rating from 1 to 5 stars, and this is a sample line, okay? So you have many movies here. We have no idea how many movies we have, but what we know that for each movie there is 10 ratings, okay? Then for almost all of the 10 times she watched Parasite, she loved it, okay? So the average is 4.6. For Apollo 11, the average is 3.1. She would like to make a chart, give the movie title, okay, then how many stars she is rating, and then at the end you say what is a movie she likes least, okay, the worst movie. So for example here you say she hates the movie called Cats, and the rating for this movie is 1.2. Okay, so what we need to do, we need to open the movie.txt and check if it is opened, find the average rating for each movie, then output the name and average rating for each movie, and which is the which movie she likes the most, sorry, the least, given that there is no tie, okay? There will be no tie in this case. Okay, so how we do this? So how we will scan through this? So how we will scan through this? So we need to go through the movies, titles, and then through the ratings. So we have here two loops, okay? One loop to go through the titles and one loop to go through ratings. What type of loop we will use here? What type of loop we will use here? Yeah, so here we will use while and here we will use for. Why while here? Because we don't know how many titles. And why for? Because we know that it will be 10 ratings. Okay. Now let's start by doing the code. So int main, this is our main function. So what we will do at the first, we need to open the file. So I will do ifstream. We will name this file as file n, and the file name is movie.txt. Okay, then we will make sure that the file is opened. So we will say if not file n. In this case, we will display unable to open file. Then we will return exit failure. We will close this. After this point, we are sure that we have the file opened. So what we should do next? So what we should do next? Yes, so we will define a string, and we call this string as movie title equal an empty string. Okay, then we will have an integer. We can call this as movie rating, and we can start by 0. So this one actually we don't need outside. Okay, so we can keep this for later. Okay, let's continue and see what we need to define. Let's leave some space, okay, and see what we need to define. So while file n into movie title. So while we can read a movie title, what we need to do inside this. Already we are reading the movie title, so what we need to do? Okay, so for loop. Okay, so we will say for an int equal 1, int less than or equal. Now here we need to see how many ratings we have. So we can define an int constant num of rating. Maybe she add more to the file. So in this case, we will say this is less than number of ratings, which in our case is 10. And then, sorry, int count equal 1. While count is less than or equal number, count plus plus. And then we have our for loop. Okay, so just we name it as count. Okay. Now what we will do here in this case, we will read file n into the movie rating. So we need to define this movie rating. What type of variable is this movie rating? Yes, it's an int. Where we should define it? Here, here, or here? No, no. Just we need it here. Int movie rating equals 0. Then we will read it. What we need to keep outside the for loop will be the total rating. Okay. So in this case, we will say int movie total rating equals 0. And in this case, we will say movie total rating plus equal movie rating. So we are accumulating all the movie ratings. Okay. Then after we accumulate all the movie ratings, we can say that the movie rating average, so movie rating average equal movie total rating divided by number of ratings to get the average. Now, what type of the average here? What should be the average? So what should be this variable? What type of this variable? It should be float. Okay, where it should be defined? It should be defined outside here. So float movie rating average equals 0. Okay, now what we need to do with this movie average? What we need to do with this movie average? We need to display it in stars, correct? We need to display it in stars. So what I did, I wrote a function to convert the rating to stars. Okay, so I wrote a function string rating to stars, and I will call it with float rating equal 0 or whatever. I can just, okay. So I wrote a function that will return a string, and this string is converting the rating into stars. Okay. Then what I will do inside here, so I have the rating as float, and I will return a string. So I will define a string, and this string called star rating equal an empty string. Then we will do an if condition. So if rating is greater than 4, Okay, in this case, sorry, yes, in this case, we will say that string, sorry, star rating equal 4 stars, sorry, 5 stars. Okay, then else f rating is greater than 3, star rating equal 4 stars. Else f rating is greater than 2, star rating equal 3 stars. Else f rating is greater than 1, then star rating equal 2 stars. Else star rating equal 1 star. Okay, so then we will return star rating and we will close this function. Can we make it? What if we have a rating of, yeah, we round it to 5, yes, whatever. This is how the no, it's not like this. It's not like this. Uh, when you have movie rating, if it exceeds 4, you get it to 5. You can do this. Okay, you have just straight values. Okay. The other way is to say, okay, here is the scale. Here is 5, 4, 5. Okay, so from 4.5 up to 5, I will consider it 5. From 3.5 up to this, so you can say 4.5, 3.5, 2.5, 1.5. Okay, but you can say if it is more than 4, I will consider it 5, and so on. Is it saying this in the question? Yeah, round it to the nearest integer. Yes. In this case, you compare with 4.5, 3.5. This is rounding to the nearest integer, correct? Okay, so you compare with 3.5, 4.5, instead of using the rounding condition. Make sense? Okay, so this will convert whatever the rating you have into stars. Okay, so if we have a rating between 4.5 and 5, you get 5 star. If the rating is more than 3.5 up to 4.5, you get 4 stars. If it is between 2.5 and 3.5, you get 3 stars. If it is between 1.5 and 2.5, you get 2 stars. Between 0 and 1.5, you get 1 star. And in this case, we can use equality or not equality. It is not that critical. So you can use equality also. Can we also do a counted loop and count a certain amount of stars? Why, Sharon? Why? Okay, so in this case, I will do the following. I will say, here we have a string, movie rating star equal an empty 1. Okay, or even we don't need this, by the way. We don't need this. Okay, because we need to display only. So in this case, I will do the following: cout movie. Sorry, I will set width as 9 because the maximum name I have for the names is 9 characters. So I will set width as 9, assuming that the maximum title name will be 9. So I will set width 9, then I will display the movie title. Then I will set width as 5 because we have maximum 5 star. And then we will display, we call the function as rating 2 stars, rating 2 stars of movie rating average. And we can display an end line, and that's it. So this will display the name. So these numbers are not magical numbers in this case. We know that the maximum number of stars is 5 stars. Okay, so set width 5 is okay. For set width 9, you can say here, assume largest name is 9 characters. Okay. Isn't movie rating getting a whole number because it's an integer division? No, because movie rating itself, yes. So here you are correct. We have to do this as double. Okay. So in this case, we have to convert this to double. Double. Thank you, Irina. Yes. Okay. Any questions so far? Any questions so far? Now, what is the problem with this? In this part of question, you are asked to write the program. Okay. Write the program. You have to write it completely. Okay. If I give you int main void and the braces, just you are writing this part. But if I ask you to, like this one, you are asked to write the complete program. Okay. In this case, you have to include the libraries. Okay. So we need to include the IO stream. We need to include the F stream. Okay. Whatever other libraries we need. So we need the IO stream. We need the F stream. We need the IO manipulation. Okay. For the set widths. Okay, now what is remaining here? So this is okay. It will display all the ratings for all the functions, but this will not display the one with the lowest rating. Okay, so we need to know which one with the lowest rating. In this case, okay, we need to define outside this an string worst movie, an empty float, and this float will be lowest rating, and we will do it as 5. We will initialize it at the maximum. Then what we will do, we will say f movie rating is less than lowest rating. In this case, worst movie equal to movie title, and lowest rating equal to movie rating. And once we finish all the movies, okay, we will display cout. Okay, and we will use this statement. Okay, she hates space. Then we will display worst movie, and then what is the movie rating. Okay, so we will display lowest rating, then end the line, return exit success, And before returning exit success, don't forget file n dot close, and we will close our main function. Should it be the average? What do you mean by the average? I think. Yeah, yes, yes. So sorry, here movie rating average. You are correct. Movie rating average. Yes, we should use the average. Yes, yes. Movie rating average. Okay, make sense how we do this? Any questions about the movie one before simulating it? Any question about this one before simulating it? So how the stars will line up? Without the set widths, if the titles lenses are different, the stars wouldn't line up. Yes, it wouldn't line up. Yes, that's why I used it here on. Okay, now any question before sharing screen and doing the code? Okay, so let me share my screen. Okay, and let's open this. Okay, so you can see my screen. Let me switch chat here so I can see the chat. You can see my screen. Okay, so here I included the libraries I need. This is a function which will convert to star. Okay, so start with an empty star rate, 5 if it is more than 4.5, 4 if it is more than 2.5, 2 if it is more than 1.5, 1 star. Then we will return this. We will open file n movie.txt. If it is not opening, unable to open. Movie name, worst movie, worst rating 5, number of ratings 10. While we can read the movie name, average rating is 0, rating total is 0. Then the for loop, we are reading the rating, we are adding them. After we finish, we are dividing this by the rating total divided by num. Here we should convert this to double, and it was working fine. I don't know why. We need to convert this to double. Then we need to convert the rating. Then we display the stars. If the average is less than the worst, we consider this as the worst. Then we say she hates this movie the most and it rated it as whatever. And we can also display how many stars this one is. Let's run the code. Okay, so here are the movies I have. Parasite, 5 stars. Apollo, 3 stars. Mommy, 3 stars. Inception, 5 stars. Rambo, 2 stars. She hates Rambo the most and rated it as 2.5, which is 2 stars. Okay. I can adjust this to be equality. Okay, so I can adjust this to be equality. In this case, it will give it 3 stars. Okay. Run this. Okay. Make sense? Any questions? I lined up the stars by this set widths. Okay, so I used set width 9 to set the width for the movie name, and set width 5 to set the width of the stars. Okay, we use set widths to align them. Is there another way to do this? Another way to do this, I can do the following. Okay, so I can add here one space. Okay, sorry. I can add spaces to make them align with each other. Okay, and I can remove the set width in this case. Okay, questions. Any questions? Any questions? Okay. Sorry, I missed it. Would be we lose marks for doing for loop C out? What do you mean for loop C out? For loop and C out star? Yes, you can use round from the CMAS, but you don't need it here. You can use round. Eh, That's fine, Aiden. Yeah, that's fine. You can do it. Okay, questions. You can use string concatenation. Yes, you can add stars. You can start with one star and start to add. Any other questions? Any other business? Sorry for because I did that, but I wonder if we can since we haven't gone over it. What I said, Renato, this is not the model answer. This is not the only solution we have. Any reasonable solution is fine. This is one way to do it. This is not the only way to do it. Okay. You are welcome. Okay. Thank you for attending. Sorry for keeping you that long, but we had two questions to go over. See you tomorrow. Um, and tomorrow we will continue our one a day. Thank you and have a good night. Thank you so much.